Okay. Okay. So, the extreme value theorem deals with maximum and minimum points because maximums and minimums can be called extrema. They're the extreme points of the graph. So an absolute maximum or minimum is the highest or lowest point on the entire function for the given domain. We've talked about this some. Did we do it in pre-cal? I think. I get pre-cal and math 3 confused sometimes because I think it might be in both. Yeah. So this is going to be the calculus view of those same things. So if f of c is the absolute minimum of f on the interval I, that's an I, not a 1, then f of c is less than or equal to f of x for all x in I, which is your interval. So if you have an absolute minimum, then that value, that minimum value is less than your function, less than or equal to your function for everything in that value. For the maximum, it's very similar. If you have an absolute maximum, then f of c is greater than or equal to f of x for all x in that interval. Absolute maximums and minimums are also sometimes called global maximums or minimums, or extrema. So any combination of that, they might use absolute or global interchangeably, and then they might use, like maximums or minimums or extrema interchangeably. Extrema is the general term that does not tell you whether it's a maximum or minimum for that. So you may see any of those terms. So a relative maximum or minimum is higher than the points around it. A point, or we could interchange lower if it is minimum. It's a point where the graph switches from increasing to decreasing or vice versa. May have forgotten what goes in that blank. If there is any containing C, then f of C is called a oh gracious, I'm going to pull up my old notes. Let's see what I put there. This is the danger with fill in the blank notes. Sometimes I don't always say things the same way. Open. Okay. I was thinking open. I really was, but I wasn't certain about it. Okay. If there is any open interval containing C on which f of C is a maximum or minimum, then f of C is called a relative, or another word that you might see used is local maximum or minimum. So the word local and relative can be used interchangeably, and you'll see both of them on the AP exam. They throw both of them out there. So let's look at this Desmos graph that I've got here. Hopefully still works. So if we look at this graph here, does it have an absolute maximum? Does it have an absolute minimum? It does not. So it would not have either one of those because this graph keeps on going up forever and down forever. However, if you can zoom in to an area where, to an open interval where you have a maximum or a minimum, then that is a relative maximum or minimum. So, for example, if I look, I'm going to do this and change the color. If I look at this only from, let's say, like negative 2 less than x less than negative 1. Let's go negative. Or let's go 0. Right there. If I just look on this interval right here, this part of this graph right here where I've turned this green, do I have an absolute maximum on that? Just that section? I do, right? So this would be an absolute maximum on that section, which means that it is a relative maximum for the graph, is what it's saying there. Same would be true down here for this minimum right here. So let's keep going. Oops, I might need to keep that open in case I forget something else. So leave that open. All right, so for this graph, we're going to find all maximums and all minimums. Okay, this one is not going to take long because you only have one, right? And we've got a minimum point right here. The coordinates for that are 3, -4. Okay. So well, I don't know if that's entirely true. Most absolute maximums can also be relative maximums. Right? So this here is an absolute minimum. But you could also call it a relative minimum. When both apply, you want to use the most specific. So this would be your absolute minimum. Now, what is important to remember, we would say that the function has an absolute minimum of -4, which occurs at x equals 3. So the way I wrote that is important because your y coordinate is your maximum or your minimum value. A lot of times sometimes they only ask for where it happens, like the x value where it occurs. So if we write it this way, the function has an absolute minimum of y value, which occurs at x value, then that will ensure that you have done it correctly. Because sometimes it asks for the minimum value, which means it's looking for the y value. Sometimes it just asks for the x value. If you write it this way, you've covered both there, and they're not going to penalize you for having the wrong thing. So the maximum or minimum value is the y value. Okay? Now, this one, we might have to estimate a little bit here too because my graph's not perfect. What do I have on this one? I have local, minimum, and maximum, right? I have a local maximum. So, local of, let's go 35, which occurs at x equals -3. Okay. I also have a local minimum. So I have a local minimum of, looks like that's probably 3, which occurs at x equals 1. Right. Okay, so y value is your maximum minimum, but you can tell where it occurs for the x. For that. Okay, here's a different graph. Okay, what do we have going on here? This graph stops. We have endpoints for this graph. Okay, what is it? Okay, that's where it's at. What is its value? 12. So we have an absolute maximum of 12, which occurs at x equals 7. Okay, what else have we got? Okay, so we have an absolute minimum of, what's our absolute minimum? -4, which occurs at x equals 3. Okay. This endpoint over here, in pre-cal, they actually said that could be like the way they defined it differently, they said that could be like a relative maximum. But the definitions they use in calculus, it cannot be, which is crazy. Why don't they talk to each other and get that one straight? I'm not sure. But what is also going to be true is that they're probably just not going to ask you about that endpoint over there. They'll ask you for absolute maximum minimum on a problem like this, and you would just give these answers for that. Okay, so here's the extreme value theorem. If f is continuous on a closed interval from a to b, then f has both a minimum and a maximum on that interval. And I really should have put absolute right there. If you see the word minimum or maximum without the phrase relative, assume it means absolute for that. So if you see it without maximum or minimum, assume that that means absolute. They're usually on AP stuff very careful to make sure they always include that word. On other things, they may not be quite as specific for that. So this is really like a pretty easy theorem. Here, it just says if you have a function and it's continuous, you have to have a maximum minimum if it's on a closed interval because it has endpoints, right? So like something like this, there's your minimum, there's your maximum. It could look like this. It could just be like a straight line. Still, you have a minimum and a maximum. What about if I had this? Yeah, you have a minimum and maximum still. They're just the same number, right? Whatever they are. So you have to have a highest point and a lowest point. Now, it could be, the only case this is going to happen is a horizontal line. It could be that they're the same, that they are, maximum, minimum is the same number. But if you have a closed interval, there has to be a highest and a lowest point. It might be the endpoints, but it might be some of the points in the middle, right? So like you can see here, it's just the endpoints. Here, your minimum is on the left side, but your maximum is that highest point. Okay? So let's figure out how to think about this. So critical numbers are points where the derivative of the function is equal to 0 or is undefined. Okay? So if we look at this graph that I have here, where would my tangent line have a slope of 0? Maximum, minimum points, right? So like right here, and right here. I'd have 3 spots where my derivative would be 0 because my slope of my tangent line would be 0. The undefined is always kind of tricky. I don't think I have one that actually is undefined here. I also think that maybe I'd graph something that was more of a looks like it has a sharp turn a little bit, so I'm not sure about that graph, but I don't think that was meant to be a vertical tangent. A lot of times they'll tell you there's a vertical tangent there if there is one, because they're kind of hard to see. So critical numbers are just any place the derivative equals 0. They are key for finding maximum and minimum points, because if your derivative equals 0, that typically shows that you are switching from increasing to decreasing. Not always. Your derivative can equal 0 in other contexts, but it most of the time is going to give you a maximum or a minimum point. So if we're just starting off finding critical numbers are where our derivative equals 0. So if I want to find critical numbers, for example, 4, I need to take the derivative. So f prime of x equals, and Webb, what do we get for that derivative? 9x squared minus 4x. And then I want to see where this derivative would equal 0 or be undefined, but is it going to be undefined? No, it's not going to be undefined because you don't have like a 0 in the denominator. So you'll just say 9x squared minus 4x equals 0. How do you solve that? Very good. You take out a GCF of the x. Don't like divide by an x. That'll make you lose an answer because there's actually going to be 2 answers here. Because once we factor out that GCF, either one of these could equal 0. So we will have x equals 0 and 9x minus 4 equals 0. So we would add that 4. So 9x will equal 4. We'll divide by 9. And x equals 4 ninths. So we've got 0 and 4 ninths would be our critical points there. These are potential maximums or minimums. You would have to do more work, and we'll learn about that in a minute to decide what it is. Okay, let's look at example 5. This derivative is a little bit more difficult to find because, Evan, what are we going to have to use to take that derivative? Quotient rule, yeah. So you could use product or quotient. If you want to use product, you'll need to move the x squared plus 1 to the top and use a negative exponent. I think I'll just do quotient rule here. I think that's what probably more of you would use. So you'll have x squared plus 1 times the derivative of 4x, which is 4, minus 4x times the derivative of x squared plus 1, which will be 2x, all over x squared plus 1. And then we just want to clean this up. Oh, yes, thank you. Squared. We want to clean that up a little bit. So we will get 4x squared plus 4 minus 8x squared over x squared plus 1 squared. And so that'll be 4 minus 4x squared over x squared plus 1 squared. That's our derivative. Everybody okay there for that derivative? All right. So we want to know where that derivative equals 0 or is undefined, right? So what is going to equal 0 if the derivative is 0? The top will equal 0 if my derivative equals 0. What equals 0 if the derivative is undefined? The bottom. So you can just take the numerator and set it equal to 0, which will, if we move that 4x squared over, look at this, we'll divide by 4, 1 equals x squared. We will square root both sides. What will we get for our answer? Oh, I love that plus or minus with that plus or minus 1. Now, the other one, we would have x squared plus 1 squared equals 0. So I could square root both sides. I got x squared plus 1 equals 0. I'd have to subtract that 1. So x squared would equal negative 1. And then I need to square root both sides. Ooh, what's wrong? It's imaginary. So do you actually get any answers for this? You do not. And you can notice that ahead of time, because if you square a number, what type of number do you get? It'll be a perfect square. And a perfect square is always positive, right? So you get a positive number, you add 1 to it, which makes it even more positive, right? And then you square it again, which, if it were somehow negative, would make it back positive again, right? There's no way that number can be negative because of what you're doing to it. Even if you start with a negative, it would end up being positive. So that can't equal 0 at any time either. No real number. So you just get positive and negative 1 for your critical numbers there. Okay, questions? All right, so why are we doing this? What are we going to do? So, extrema on a closed interval can only occur at the endpoints of the interval or at your critical numbers. So this is key right here. So if they're asking you for absolute extrema, they can only happen at the endpoints or where your derivative is 0 or undefined. Okay? So we'll see mostly questions like example 6 here. Find the absolute extrema of f of x equals 2x to the third plus 3x squared on the interval -2 to 1. Okay? So what we need to do first is find our critical points. So to find our critical points, we will take our first derivative. So if I take my derivative here, I will get 6x squared plus 6x. And then I want to see where that equals 0 or is undefined, but it can only be equal to 0 for this one. So I'll have 6x squared plus 6x equals 0. And what would I do here? GCF. So you can pull out a 6x, and then you'll have an x plus 1. So you'll have that 6x equals 0, which if you divide that by 6 just gives you x equals 0. And then you'll have x plus 1 equals 0, which just gives you -1. So I have critical points at 0 and at -1. Are those on the interval that I'm looking at? Yes, they are both on that interval. So I need to consider both of them. If I get a critical point that's not on the interval that I'm looking at, I just throw it out and don't worry about it because it wouldn't apply to this situation. So now you can just test your candidates to see which one's maximums, which one's a minimum. So what you're going to do here is you're just going to find, you want to go back to the original function, not the derivative. So you're going to find f of -2. So 2 times -2 cubed plus 3 times -2 squared is going to be, see, that'll be -8, -16, 4 plus 12, so that will give us -4. And I like going lowest to highest, so I'm going to do -1 next. So 2 times -1 cubed plus 3 times -1 squared. I'm using my critical points because I kind of like to do like the low. So our candidates that we could possibly test are the endpoints right here or the critical points. So it could be any of those numbers. So, we've got to check them all. The only time you wouldn't check one of them is if maybe it didn't fall on the interval that you were looking at. So I was just doing lowest to highest, but it doesn't matter what order you do them in, so you could definitely do the positive one next if you'd already started that. So this will be -2 plus 3, which will give us a +1. I'm going to do f of 0 next, which is just going to be 2 times 0 cubed plus 3 times 0 squared. That's just going to give us 0. And then I'm going to plug in 1 last. And so I'll have 2 times 1 cubed plus 3 times 1 squared. And that is just going to be 2 plus 3, so I get 5. So, you're just looking for the highest and the lowest number of these because the extrema can only happen at the critical points or the end points. So whatever number is the highest, that's your absolute maximum. Whatever number is the lowest, that's your absolute minimum. So for your minimum, that's going to be the -4. So we would say the absolute minimum is -4, which occurs at x equals -2. And then our maximum, our highest number is 5. So the absolute maximum is 5, which occurs at x equals 1. So it actually ended up being the endpoints here. It's not the critical points, but you always have to check those. Okay, questions? Critical points are places where your derivative is 0 or undefined. So critical points are places where your derivative is 0 or undefined, which often are maximum or minimum points. If you look at this one right here, what's that? 2x to the third plus 3x squared. Oh wait, precious me. All right, 2x to the third plus 3x squared. So at -1 and at 0, you have relative maximum minimums, but they don't end up being absolute for this one. And we'll learn more like throughout the week on how to find relative maximum minimums. Today we're really just focusing on those absolute for that. Okay, let's keep going. All right, we are supposed to find the global extrema of f of x equals 2x minus 3x to the 2/3 on the interval from -1 to 3. So we've got to find the derivative, find the critical points, then test all of our candidates there. So in this case, our derivative is going to be 2 minus, and I'll have to do 3 times 2/3, which will just give me 2, and then x to the -1/3 there. And before you set this equal to 0, it might be helpful to send that negative exponent back down to the bottom and maybe even change it to a root there. So my critical points are going to be places where I have the derivative equal to 0 or undefined. What would make this undefined? If x equals 0. So you definitely have a critical point at x equals 0. To find where the derivative would equal 0, we'll just take 2 minus 2 over the cube root of x and set that equal to 0. So I would probably just move all of this over to the other side, which will make it positive. So you'll get 2 equals 2 over the cube root of x. What would you guys do next? multiply by the cube root of x, because you're not going to be able to do anything with that while it's in the denominator. So that gives you 2 times the cube root of x equals 2. You will need to divide by that 2. So the cube root of x equals 1. And what's the last step I need to do? Cube both sides to get rid of that cube root, and x just ends up equaling 1. If you're raising it to a power to get rid of a root, you do not do a plus or minus. And if it's a cube root, you wouldn't do it anyway. Like if we were doing a cube root of both sides, those can be negative for that. It's only even roots. But if we're getting rid of the cube root, you don't need a plus or minus for that. So our critical points are 0, 1, and 1. Those are our 2 critical points. And we would also need to include -1 and 3 because those are our endpoints. For the sake of time, and I'm okay with you doing this on your assignment as well, I'm going to do this. I am going to type this equation into Desmos. So I got 2x minus 3x to the 2/3 power right there, and then I am this would not be calculator active on the actual test. I just know that this is gonna. Oh, should I make you do at least one of these? You guys can take a cube root though, can't you? You'll be okay. Because it would not be calculator active. Because if it was calculator active, you could just graph it and look at it. So they won't make it calculator active. But for the sake of time here, I'm just going to do f of -1, f of 0, f of 1, and f of 3. All of my candidates. I might should do this by hand to show you how you can tell. I'm trying to cheat. I'm trying to cheat a little bit here because it's taking a while. Alright, so f of -1 gives you -5. F of 0 equals 0. F of 1 equals -1. Let's do f of 3 by hand so you can see what you get. F of 3 is going to be 2 times 3 minus 3 times 3 to the 2/3 there, which is going to be 6 minus 3 times the cube root of 3 squared. Or that could be written 6 minus 3 times the cube root of 9. Now, this might happen to you on a calculator inactive problem. So these 3 you would have to do by hand. You could figure those out and get whole numbers. But then we've got this one that is 6 minus 3 cube root of 9, and cube root of 9 we do not know. We know the square root of 9, but we do not know the cube root of 9. So that makes it a little difficult to figure out which one's highest and which one's lowest. So we are going to do like an estimate here, but do it in your head. Do not write it down, okay? So you don't want to write down your estimate, and you definitely don't want to write down your estimate with an equal sign, right? Because it's not equal. It is permissible for you to do an estimate like this with the squiggly equal sign, but I would discourage you from even writing it down, because if you forget and put a regular equal sign, you're going to lose a point on this. But this would be about 6 minus 3 times cube root of 9. What's it going to be close to? It's going to be a little bigger than 2, right? Because the cube root of 8 would be 2. So maybe this is about 2.1. Are we going to get a positive or negative number there? We'll get a negative number. So is it our maximum? No. It's definitely not our maximum. 0 right here is going to be our max. Is it our minimum? I don't think so. It's not going to be lower than negative 5, right? So that would be your minimum right there. So you may get something like this where you kind of have to estimate. I would do it all in my head, and I wouldn't even write that right there down because it's not actually equal to that value. But that's sort of what you're thinking through. So we would say that F has a minimum of negative 5 at x equals negative 1, and F has a maximum of 0 at x equals 0. Okay, so you got to see, you find the derivative, set it equal to 0 or undefined to get your critical points. Then you're going to test all of your candidates to see which one's highest and which one's lowest. Now let's see. All right, let's do 9. And we'll probably talk about 10, and that'll be about all we have time for. So if I'm looking for my extrema here, I've got to find the derivative, which is going to be 2 cosine x. What will I get right here? What's my derivative of cosine? Negative sine of 2x. But what do I have to do there? It is a tiny little chain rule. This is the inside part, right? So what do I have to multiply this by? 2. And because it was already a minus and I have negative sign, that'll become a positive there. Let me write that so that's not confusing. So you had a minus, and then you get negative sine of 2x, and then you have to multiply that by 2. So that negative times the negative becomes positive, and then you've got that 2 right there. Okay, so if you were looking for where this equals 0, it's not going to be undefined because sine and cosine don't have any places where they're undefined. I've got 2 cosine x plus 2 sine of 2x right here. Which I think I'm going to have to use double angle identity for. Pretty sure. Anybody remember it? Okay. Double angle identity. This is from pre-cal. Sine of 2x is 2 sine x cosine x. Okay, so that's one of those we had from pre-cal that we've probably forgotten. There. Yeah. So we can replace sine of 2x with 2 sine x cosine x here. So that's 2 cosine x plus 4 sine x cosine x equals 0. What are we going to do there? It is better to pull out a cosine x. if you move the 2 cosine x to the other side and divide by cosine, you're going to lose one of the answers. So it's best to do a GCF here. You can pull out just a cosine x or a 2 cosine x. It doesn't matter here. I think I'll take a 2 cosine x. And so it'll be 1 plus 4 sine x equals 0. Yes, it should. Thank you. And it needs to be because I was just thinking there's no way I can get unit circle values for that. So if you find yourself like dividing by an x that cancels or dividing by a sine x that cancels, you probably lost a value there. So if it's possible to factor, you want to do that instead. So we got 2 cosine x equals 0 and 1 plus 2 sine x equals 0. And so I'll just divide by 2 here. Cosine x equals 0. Where does cosine of x equal 0? Pi over 2 and 3 pi over 2. And yeah, they got us looking from 0 to 2 pi, so we got to do that. And then here we'll get 2 sine x equals -1, and we'll divide by that 2. So we're looking for where sine of x equals -1/2. That's going to require a little thought on the unit circle, isn't it? So like right here, this is √3 over 2 1/2, but we want negative. So that's going to be right here. So that'll be √3 over 2 -1/2. And also over here in the third quadrant. There. So that'll be 11 pi over 6. Where else? What's that third quadrant value? 7 pi over 6. Yes, you will. And because I know that like this can take forever, this would not be a calculator active problem, but on your homework you can use your calculator to help you so that it does not take you 5 hours to do the homework. Alright, so if we get, let's see, we got f of x equals 2 sine x minus cosine 2x. And let me make sure I am in radians. Yes. So if I do f of 0, f of pi over 2, f of 3 pi over 2, f of 7 pi over 6, f of 11 pi over 6, and f of 2 pi. Okay. What is the highest number that I get there? At pi over 2, 3. So I could say f has a maximum of 3, which occurs at x equals pi over 2. What's the minimum? Very good. Those are the x coordinates where it happens. So I have a minimum of -1, wait, 0.5. Oh, sorry. At x equals 7 pi over 6 and 11 pi over 6. Okay, let me look at the assignment and see. Too much. It will be short. It will be shortened. Let me look at it real quick. Just not enough time. 17. 7 through 10 are graphs. You can still do those. 21 through 31 odd. Let's not do these last ones. We might look at them later.
Is it all on 217?
Yeah. Yes, all of that is on 217. And 7 through 10 are just graphs that you're just looking at. They should take no time. 21 through 31 are problems where you're finding those values, and 35 is as well.
Are you going to update that on Canvas?